Note card number 38, here we go. First derivative test for local extrema. So we are putting together the skills that we've learned in the past couple of days, and we are going to use our knowledge of critical points and increasing and decreasing slope in order to find our local extrema, which we will remember are our maximums and our minimums. All right, so all of this work is going to be based on the idea that in order to have a maximum, my graph must be increasing and then change to decreasing, right? So anytime that happens, when we go from increasing to decreasing, we must have a maximum there. And then kind of by the same idea, if we have a decreasing that then changes to increasing, right? Then we must have a minimum there, okay? And at both of these points, at your maximum and your minimum, we will remember that our derivative is equal to 0, right? We've got a horizontal tangent line, like my line going right here and right here, so that means it must have a slope of 0. So what we're going to do in order to find our maximum and minimums today is we're going to find our critical points, or again, where our derivative is equal to 0, and then we're going to test them to see if they are maximums or if they are minimums, okay? So here we go, looking at number 1. Number 1 asks us for where the function has a relative maximum, okay? So in order to do that, I need to find my critical points. We should hopefully be getting pretty good at finding our critical points now. Let's take the derivative, and we will set that equal to 0. Then I can factor this out. They both have a 3x in common, so I'd have x minus 2 equals 0. So x would equal 0, and x would equal 2. These are now my critical values, or critical points. I'm going to put them on a number line like I did in the last video. So I've got 0 and 2, and we're going to test to see if my graph is increasing or decreasing here. Remember, to do that, we want to plug into our derivative because we care if the slope is positive, it's increasing, and if the slope is negative. And slope, we want to use the derivative formula. Okay, so we're going to take a number to the left of 0, so we'll try -1. If I plug it into my factored form, I would have a negative times a negative, which would give me a positive. So this is positive here. In between 0 and 2, I'm going to pick 1. It's a nice, easy number to plug in. I've got a positive and I've got a negative. Positive times negative would give me a negative. Okay. And then to the right of this, plugging in 3, I've got a positive times a positive, which would give me a positive. Okay. So therefore, if the slope is positive, that means my original must be increasing. And then here, if the slope is negative, my original must be decreasing, and then it must be increasing again. So drawing this really helps us to see where we have minimums and maximums, right? Up here, we're going up to down, so we must have a maximum at 0. And then here, we're going down to up, so we must have a minimum, okay? The question asked us at what x value do we have a maximum? So all we have to do here is say that at x equals 0, we have a maximum there. Number 2 gives us this equation and asks us to state any local extrema. Okay, so we're going to find any local extrema the same way. I'm going to rewrite this function so it's easier for me to use the power rule. So I'm not taking the derivative yet. I'm just using my negative exponents to rewrite that. Now I can take the derivative of that. My y prime would be power rule. I move the -2 to the front, and then I subtract 1, -3. And I know that that is the same as -2 over x cubed. Again, that negative exponent meaning put it in the bottom. The -2 did not have a negative exponent, so it stays on the top. And I want the top or the bottom to equal 0. Remember, we need to figure out for a critical point where this equals 0 or where it's undefined. And where it's undefined is when the denominator equals 0. So the only time the x cubed is going to equal 0 is if x itself equals 0. So that must be my only critical value. I'm going to make my number line here. And we are going to put 0 here. Okay. And we're going to plug in -1 into this here. I would have a negative over a negative, which would give me a positive. And then I would have a negative over a positive, which would give me a negative. So my graph should be going like this, okay? However, in AP Calculus, we have to be critical thinkers here. Think about what this graph would look like, right? I'm going to have a problem here because at x equals 0, I'm actually going to have a vertical asymptote, right? I am not allowed to plug in 0 here. It would give me undefined. So because I would have a vertical asymptote here, I actually would not have, even though it looks like this might be a maximum, I need to use my prior knowledge about vertical asymptotes and realize that, no, that would not actually give me a maximum. It would give me a graph that's looking like this, right? Something like this, okay? So because of that, I actually have no local extrema. So keep an eye out for that, especially when your critical points come from undefined places, right? We need to be really, really careful that we are considering, is it an asymptote or is it actually going to be a maximum? Number 3 asks us to find the relative maximum value. So hopefully we're getting it to at this point to know what we should do next, right? We need to take the derivative. I'm going to find my critical points. So I'm going to take the derivative here. This is the product rule, very similar to one we did in the last video. I'm going to make this is my first, this is my second. So I'm going to do second times the derivative of the first plus the first times the derivative of the second. Remember, the derivative of e to the x is itself. This is just a simple x, so I don't need to worry about the chain rule. Okay. Now, in the last video, we talked about factoring this out. Look for what they have in common. They both have an e to the x in common. So I'm going to pull e to the x to the front, and then I would have 2x plus x squared minus 3, and I want that to equal 0. I would need e to the x to equal 0, but that is impossible. No exponent there will give us a value of 0. This I'm going to rearrange and then factor. I've got x squared plus 2x minus 3 equals 0. So x plus 3 and x minus 1. So my critical points are at -3 and 1. Running out of space here, but I'm going to draw my number line kind of small over here. So I've got -3 and 1 right there. Okay, I'll draw this so that it, whoops, so we're looking at our number line there. All right, so I'm going to plug in something to the left, so -4. If I plug in -4, this would be some kind of a decimal. Then I'd have -8 plus 16 minus 3, so we would have a positive there. In the middle, I could plug in 0. That would make this 1. 0, 0, -3, so I'd have a minus. And then if I plug in 2, I would have a positive value times 4 plus 4 minus 3. We have enough positive values there to make it positive. Okay. Now, this one asks for the relative maximum. So I'm looking where something's going up and then down, which is happening at -3. So I would say that I have a maximum at x equals -3. Okay. It then, though, asks me to find the relative maximum value. So there's a huge difference here that we need to talk about. So if a question asks me, where is it happening? That's asking me for the x value. Okay. If it's asking what is the maximum value, oh, sorry, I just realized that's on the screen. So where is the x value? What asks me for actually the y value? So we found that x was equal to -3, but I need to figure out what that maximum is. Okay. So I'm gonna have to plug that back into my original, which was this, x squared minus 3 times e to the x. Plugging in -3, I would have -3 squared, 9 minus 3 times e to the -3. And this was not a calculator problem, so I'm just going to leave it like this. I've got 9 minus 3 would be 6. And then I can either write it like this, or I could say 6 over e cubed using my negative exponent rules. Either of those would be correct, and because it's not a calculator question, this is all that the AP expects from us. We can leave it in either of those forms. Last problem for this video, we are going to find where the minimum value, or sorry, it says what is the minimum value, so we're going to actually need the y value in this case. First we have to find the x though, so we are going to take the derivative. Notice those 2 stars on your paper mean this is a calculator question, so we might use a calculator here. This is my first, this is my second, so second times the derivative of the first is just 1, plus the first times derivative of the second is this, and this is just a normal x, so I don't need to think about chain rule. Simplifying this, I have the ln of x plus 1 is equal to 0. So I need to figure out where the ln of x is equal to -1. Okay, this is the same as the ln, remember, is log base e to the x equals -1. So I can use my wraparound that we learned in Algebra 2. I'm going to say e to the -1 equals x. So x is 1 over e. Now I'm going to make my number line. 1 over e. So I need to check something to the left of 1 over e. So in my calculator I can figure out what 1 over e is. And again, this is a calculator question, which I know because we've got some stars next to it. So I'm going to do second, and then the e button is right here. just to figure it. So we're at 0.367. So I'm going to plug in something a little bit less than that. Let's plug in 0.25 into my original here. So I would have the ln of 0.25 and then plus 1. And that gives me a negative value here. So this side must be negative. Then to this side, I'm guessing it will be positive, but let's double check. Let's just try to plug in 1. So the ln of 1 would be 0, plus 1 would be a positive number. There you go. So we had to do that to check, even though we just have one critical number, I need to make sure that this is actually a minimum, which is what the problem is asking me for. And since it is decreasing and then increasing, that does mean that I would have a minimum here, okay? So this is the x value, but it didn't ask me where is my minimum. It asked me what is my minimum. So I'm now gonna have to take this value and plug it in back to my original up here. So I would have 1 over e ln of 1 over e. This, the ln of 1 over e, so e to what power is giving me 1 over e? That would be negative 1. So I would have 1 over e times negative 1. So my minimum value must be negative 1 over e. And there is my solution.